Linear correlation. Linear correlation coefficient. For a set of n data points, the linear correlation coefficient R is defined by R equals 1 over 1 minus n times the sum of parentheses x sub I minus x bar close parentheses times parenthesis y sub I minus y bar close parentheses, all divided by s sub x times s sub y, where s sub x and s sub y denote the sample standard deviation of the x values and y values respectively. Computing formula for a linear correlation coefficient. The computing formula for a linear correlation coefficient is R equals the sum of x sub I times y sub I minus the sum of x sub I times the sum of y sub I divided by n, all over the square root of, open parenthesis, the sum of x sub I squared minus, open parenthesis, the sum of x sub I, close parenthesis, squared divided by n, close parenthesis, times, open parenthesis, the sum of y sub I squared minus, open parenthesis, the sum of y sub I, close parenthesis, squared divided by n, close parentheses. Various degrees of linear correlation. For our first graph, we have an example of perfect positive linear correlation when R equals 1. All my dots for my scatter plot are on the regression line, and it increases from left to right. The second graph we have is strong positive linear correlation, R equals 0.9. In this case, our scatter plot is clustered very closely around our regression line, and it increases from left to right. Our third graph is a weak positive linear correlation, R equals 0.4. Here, my line for my linear regression increases from left to right. The scatter pattern of my data is far removed from the line for my linear regression. My next graph, I have an example of perfect negative linear correlation, R equals -1. Here, my scatter plot is on the line for my linear regression, and my line goes down from left to right. My next graph has a strong negative correlation, where R equals -0.9. My linear regression line still goes down from left to right, but my scatter plot is grouped around my line. My next graph is a weak negative linear correlation where R equals -0.4. My linear regression line still goes down from left to right. However, my data for my scatter plot is around the line with very few points close to the line. My next graph shows a scatter plot with no linear correlation, or linearly uncorrelated, R equals 0. Here, the dots do not form any kind of line. They're just spread out, and we can't tell what shape our data could take. Relationship between the correlation coefficient and the coefficient of determination. The coefficient of determination equals the square of the linear correlation coefficient. So our coefficient of determination is R squared, and our correlation coefficient is R. Example: the coefficient of determination of a set of data points is 0.626, and the slope of the regression line is 3.15. What is the linear correlation coefficient? Since we are given our coefficient of determination, we know that R squared equals 0.626. I can find my linear correlation coefficient by taking the square root of 0.626. So R would equal plus or minus 0.791. I look at my original problem and I'm told the slope of this line is 3.15. Since the slope is positive, R equals 0.791. Example, the following are the age in years and price in hundreds of dollars for a certain type of car. A scatterplot of the data is given to the right. So we have a graph of our data. Our x values go from 0 to 10, and our y values go from 200 to 500. Our data looks like it can form a line, and it goes down from left to right. Age is x, price is y. My data points are when x is 7, y is 269. When x is 7, y is 258. When x is 7, y is 277. When x is 2, y is 405. When x is 3, y is 365. When x is 4, y is 299. When x is 5, y is 331. When x is 4, y is 314. When x is 1, y is 408. When x is 4, y is 310. Obtain the linear correlation coefficient. I want to go to my calculator. First, I need to type my data in my lists. So I go to Stat, Edit, X goes in L1, 7, 7, 7, 2, 3, 4, 5, 4, 1, 4. L2 will have my y values, 269, 258, 277, 405, 365, 299, 331, 314, 408, 310. Now I'm ready to find the linear regression. Stat, over to Calc. I want number 4, linear regression. My X list is L1, my Y list is L2. I don't have a frequency list, and I don't need the y equals equation. So I'm going to go to Calculate, Enter. R equals negative 0.92989. Rounding to 3 decimal places, R equals negative 0.930. Continuing with our example, interpret the value of R in terms of the relationship between the two variables. Since R is negative, we know we have a negative slope. There is a strong negative linear association between the two variables. This is because negative 0.930 is very close to negative 1. Continuing, discuss the graphical interpretation of the value of R. The given graph is consistent with the interpretation found because the y values appear to decrease as the x values increase, and the data points appear clustered closely about the regression line. Continuing, obtain the value of the coefficient of determination. One option we have is taking R and squaring it, which gives us 0.8649. Example, the following are the weight in grams and the quantity of volatile emissions in hundreds of nanograms for plants. A scatter plot of the data is given to the right. We have a graph of our dots. Our x values go from 40 to 100. Our y values go from 0 to 30. My data points look like they're fairly spread out. My table gives a weight, that's my x value, and a quantity, which is my y value. When x is 57, y is 8.0. When x is 86, y is 21.0. When x is 56, y is 10.5. When x is 64, y is 22.5. When x is 54, y is 12.5. When x is 68, y is 11.5. When x is 64, y is 7.5. When x is 81, y is 13.5. When x is 75, y is 17.5. And when x is 52, y is 22.0. Obtain the linear correlation coefficient. In order to do this, we need to type our data into our lists on our calculator. Stat, Edit, I'm going to move over to L1, and I can either type over this data, or I can always arrow up, clear, enter. 57, 86, 56, 64, 54, 68, 64, 81, 75, 52. I'm going to move over to L2 and arrow up to type in my y values. 8, 21, 10.5, 22.5, 12.5, 11.5, 7.5, 13.5, 17.5, 22. Now I can go to Stat, over to Calc, number 4 for linear regression. My X list is L1, my Y list is L2. I'm going to leave frequency list and the store regression equation blank, calculate, and for R I get 0.252488. Rounding to 3 decimal places, that gives me R equals 0.252. Continuing, interpret the value of R in terms of the linear relationship between the two variables. Since 0.252 is much closer to 0 than to 1, there is a weak positive linear association between the two variables. Continuing, discuss the graphical interpretation of the value of R. The given graph is consistent with the interpretation found because the y values appear to increase as the x values increase, and the data points appear wildly scattered about the regression line. Continuing, obtain the value of the coefficient of determination. One option I have is to square R. R squared equals 0.252 squared, which is 0.064. Recapping, linear correlation. Linear correlation coefficient is R. Various degrees of linear correlation. R can tell us how strong or weak the correlation is, depending on if it's close to -1, 0, or +1. The closer it is to -1, the stronger our negative linear correlation will be. The closer it is to +1, the stronger our positive linear correlation will be. The closer it is to 0, the less of a correlation we have, whether it's positive or negative.